Welcome. Up till now we have seen introduction to the Bevel Gear, classification of Bevel Gear, terminology used in the Bevel Gear, virtual number of teeth, force analysis in case of Bevel Gear, and beam strength of Bevel Gear. Now we will see remaining part, wear strength of Bevel Gears. The contact between two meshing teeth of straight Bevel Gears is a line contact, which is similar to that of spur gears. In order to determine the wear strength, the bevel gear is considered to be equivalent to a formative spur gear in a plane which is perpendicular to the tooth at the large end. Applying Buckingham's equation to these formative gears, we have SW is equal to BQ dP-K equation 1, where B is equal to face width of the gears in mm, Q is equal to ratio factor, dP- is equal to pitch circle diameter of formative pinion in mm, K is equal to material constant in Newton per mm square. The pitch circle diameter of the formative pinion is given by dP- is equal to 2rp. Therefore, dP- is equal to capital DP upon cos gamma equation 2, where capital DP is the pitch circle diameter of the pinion at the large end of the tooth. From equation 1 and 2 we have SW is equal to BQ dPk upon cos gamma equation 3. In case of bevel gears, either the pinion or the gear is generally overhanging. It is subjected to deflection under the action of tooth forces, and it has been found that to transmit the load, only 3/4 of the face width is effective. Therefore, modifying equation 3 to account for this effect, we have SW is equal to 0.75 BQ/dPk divided by cos gamma equation 4. Equation 4 is known as Buckingham's equation for the wear strength of bevel gears. The equation is derived for the formative pair of pinion and gear. The ratio factor Q is therefore given by Q is equal to 2ZG upon ZG plus ZP equation 5, where ZP is equal to ZP upon cos gamma and ZG is equal to ZG upon cos of large gamma, which is equal to Zg upon sine of 90 minus gamma. Therefore, Zg is equal to Zg upon sine gamma. Substituting above values of Zp and Zg in equation 5, we have Q is equal to 2Zg divided by Zg plus Zp tan gamma equation 6. The material constant K is the same as for spur gears and is given by K is equal to sigma c square sin alpha cos alpha into bracket 1 upon EP plus 1 upon EG divided by 1.4 equation 7. When the pinion as well as the gear is made of steel and the pressure angle is 20 degree, the value of K is given by K is equal to 0.16 into bracket BHN divided by 100 bracket square equation 8. The wear strength SW indicates the maximum value of the tangential force at the large end of the tooth that the tooth can transmit without pitting failure. It should be more than the effective force between the meshing tooth. Now next, effective load on gear tooth. The tangential component due to power transmission considered to be acting at the large end of the tooth is determined by using the following two equations. That is, torque transmitted is equal to 16 to 10 raised to 6 into power transmission in kilowatt divided by 2 pi np. Therefore, tangential load Pt is equal to 2 mt divided by d. In addition to the tangential component due to power transmission, there is the dynamic load. There are two methods to account for the dynamic load: an approximate estimation by means of the velocity factor in the preliminary stages of gear design, and a precise calculation by Buckinghams equation in the final stages. The effective load P effective between two meshing teeth is given by P effective is equal to CSPT upon CV, equation 1, where CS is equal to service factor, CV is equal to velocity factor. The velocity factor for cut teeth is given by CV is equal to 6 upon 6 plus V, equation 2. The velocity factor for generated teeth is given by CV is equal to 5.6 divided by 5.6 plus root V, equation 3, where V is the pitch line velocity in meter per second. In the final stages of gear design, the dynamic load is determined by the equation derived by Professor M. F. Spot. Bevel gears are usually made of steel, and the dynamic load is given by PD is equal to E N P Z P P dash RMP into RMG divided by 2.30 into square root of RMP square plus RMG square, equation 4. In the above equation, RMP and RMG are radii of the pinion and gear respectively at the midpoint of the tooth. B dash is the axial width of the gear blank. B dash is equal to B cos gamma, where RMP is equal to dP divided by 2 minus B sin gamma divided by 2, and RMG is equal to dG divided by 2 minus B cos gamma divided by 2. The effective load is given by P effective equal to CSPT plus PD, equation 5. In order to avoid the gear tooth due to bending, SB is equal to P effective into factor of safety, equation 6. In order to avoid failure of the gear tooth due to pitting, SW is equal to P effective into factor of safety, equation 7. Equation 6 and 7 are used to design bevel gears. Therefore, this is the end of the theory of the bevel gears. Thank you very much.